When you define a class like a bank account here, in professional world, what we typically do is we split class definition into two files and having a multi-file project. The reason why we do so is for effectively handling the program structures and then effectively compiling to build the entire project. So if you have a one class, then one class definition is separate into two, and then the like main function and others are called application part becomes another file as well. So the basic rule is that in multi-file project for each class, you separate into two files, class name .h and the class name .cpp. Class name .h is called the interface, and the .cpp file is called the implementation of the class. So what you put in .h file is the structure of the class and then the names of the functions or prototype of the functions. So variable names, which is the internal structure of the bank account class, goes to .h file, and then the function definitions only prototype. Prototype means return type, name of the function, and then parameters. So prior to curly brace, that's prototype. That part goes to .h. So here, here, and here, only prototype goes to the .h. And then in .cpp, all the implementation, the entire function implementation goes to .cpp file. So let's split the class definition into two to prepare for multi-file project. So let me erase the screen. So first, let me define bank account.h. The file name you could give any, but the professional convention is give a class name and .h. In this .h interface part, what you do is let me copy the entire class definition and paste into this one. So you give the variable called a member variable name, and then the functions we give a prototype of a functions only. So delete those one. Since we gave a prototype only, we terminate by semicolon. So function without the body part is called the prototype. So function prototypes only, and then member variables only. Here, since I'm using string library, so I need to include a string library. Then all the errors are gone. So the interface of a bank account class, I created the .h file, and the implementation, I need to create a bank account .cpp. So in this, I give implementation of all member functions defined in the bank account class. So let me anyway copy all the functions implementations and then paste it here. Then we need to do a few things. So here in this file alone, I see that avoid set ID parameter and so on. Then this could be just an independent function not related to the bank account at all. But here, the definition of a set ID function is only for bank account class. So to do so, we have a special syntax such that when you give a member function definition after the type, here is a void, you give a class name, which is a bank account, and then give two columns, a colon. That's the syntax for defining member function of a class. Here I have an error because the bank account is not recognized. So that is a bank account class. The idea is defined here in .h file. So I need to include .h interface definition. Now the .h file is at the current location, same location with the .cpp. If I include from the library, I use this angle bracket, but I'm using my own definition, so I use double quotes instead of angle bracket, and then there's the same location with the .cpp, so just do bank account.h. Then the bank account, I have actually typo here, counter, so it is now correctly recognized. So do the same thing for other member functions. So here get ID is a bank account class member function. So let me do that way. Get balance is also bank account member function. Set balance bank account member function. Then the first step, defining a class into two files, .h and .cpp, is done. Then in main program, the bank account class, I can delete it now, separate it from application code. Then bank account is not recognized within this main.cpp, so what we need to do is include bank account.h. We don't include the .cpp, only .h, which includes the structure of the bank account. So I have separated into three files. Then the rationale behind this separation is as follows. In .h, as you compile, you cannot compile this .h alone, because .h, you don't have any executable code. What you got from .h is the structure of a bank account class, so that as you create the bank account variable, which we call object. So in terminology, at this moment, a variable of a class type is called object. So the detailed meaning of that in programming paradigm we are going to learn later. So object B1, the structure is defined in .h file. I don't need a .cpp to find the structure of a B1. So if a main.cpp is translated, what compiler needs to know is what is the structure of a B1. B1 structure is something like we have ID, name, and balance, and it has several member functions. That's all the compiler needs to translate the main function. So that's why we need a .h file only. And in .cpp now has executable code, assignment and returning something and the like. So when you compile this program, you can actually compile each file separately if there is an executable code. So in this project, main.cpp has executable code. The bank account.cpp has executable code, but .h file interface definition does not have a executable code. But to generate the executable code here at this moment, the structure information is needed. That's why we include such definitions. So I have three files now, and to compile and run, I do these steps. So G++ has, of course, -G option for debugging symbol generation. Another option is called the -C, which is called the compile only. Then if I do bank account.cpp, then bank account.o is produced. So what it does is as follows. So I have a bank account.cpp, and then I translate it with the -C option. I have a bank account.o file. So bank account.o file is translation of this C++ program into a machine language for this computer. And then this one is just a simple translation from the code definition to corresponding machine code. That's it. And then another CPP file could be translated as well. So main.cpp, as I compile with the -c option, it will produce a main.o, which is just a one-to-one translation of those C++ code into machine language. And then let me do that here. So G++ minus C option main.cpp, then main.o is produced now. So I have a bank account.o and the main.o, and then finally what I need to do is I need to put these together with the library. So in main.cpp I have included iostream and string and so on. So there is a library provided by C++ as iostream and the string and the like. So those ones should be put together, and then ultimately it produces a out. So this is a final executable code. And then to putting them together with the included library, the C command is a G++. Without the C, minus G is we keep using that for debugging symbol, but if you don't need the debugging, you don't need to give a minus G at all. But without the minus C, now I want to put together bank account.o and then main.o. And then this produces a out. A.out was there because of the previous exercise. So if I delete A.out completely, then if I use this one again, A.out is produced, and then A.out is the executable code. And then if we do this multi-file project, the advantage of doing so is at this scenario, so bank account.cpp translates into .o, main.cpp translates into .main.o correspondingly. So which means if I change something in main.cpp, so for example here, I just create another bank account B2, and then in B2 I do set ID is a 3, and then let's print ID of B2 and the like. So in this case I have edited the main.cpp only, so that bank account.cpp I don't have to compile again. It's a bank account.o is a valid. Only I produce main.o since I changed the main.cpp and then put them together. That will work. So G++ minus C main.cpp I have edited. So I need to reproduce or compile again the main.o, and then I can simply put together main.o, and then I can continue to use bank account.o that was compiled earlier, since I did not change bank account.cpp at all. Then put together and then run the program. So B2, 3, that is printed. So if I change bank account.cpp something here, so instead of returning balance, I would say that just for testing. So let me, when you set the balance, let's increment the balance by 1. So this may not be correct logic though. Suppose I just changed the bank account.cpp, then to run the whole project, I need to recompile -c bank account.cpp recompile, but I don't have to recompile main.cpp. I can use the same main.cpp So I mean that all already translated and the bank account that all just translated as a fresh, then put together and then run it. Then the balance, as we see that set balance, the +1 is done in main that's bank account implementation. So incremented one is there. So here the advantage of using multi-file project is you can see the benefit that if you have a huge number of files because of you use a huge number of classes, then if you edit some of them, you don't have to recompile the entire thing. You just compile the ones you edited. So that's the main reason why you use a multi-file project.